Welcome to the Computing and Systems program at North Carolina State University in the Department of Civil, Construction, and Environmental Engineering. The interest of the Computing and Systems program is to develop innovative software and computer-based solutions for analyzing, designing, and managing civil engineering systems. Our coursework and research focus on the use of systems concepts to build models to find solutions to complex problems. The Computing and Systems program is an interdisciplinary group made up of faculty that have expertise in computing and systems and in traditional areas of civil engineering, including environmental and water resources engineering, coastal engineering, and structural engineering. The emphasis of our research program is to develop new computing and methodological tools to solve infrastructure and environmental systems problems. Our research has four core areas. Research focused on high-performance computing develops and applies parallel and distributed computing and concurrent systems to execute applications that require long running times and to analyze performance. For example, we develop groundwater simulations, simulation of coastal areas, and heuristic optimization methods for parallel computing. We also conduct research in new areas of software engineering to develop programming methodologies and formal approaches for reasoning about computer systems. Several faculty conduct research in systems and optimization. They develop and apply new mathematical models and optimization methods within decision support systems to identify management strategies. Research also develops and applies forecasting and data assimilation, along with uncertainty analysis, to assess the impacts of climate change on environmental systems. Numerical methods are also applied in finite element methods to simulate complex infrastructure systems. Each faculty member in the group shares expertise in computing and systems and in general civil engineering domains. The group is cross-disciplinary and contributes to research in structures and mechanics, environmental, water, and coastal engineering, and construction engineering. We also teach both graduate and undergraduate courses within the civil engineering department to cover modeling, systems analysis, and computing topics. Some courses are offered as special topics graduate courses, and others, such as computer methods and applications and numerical methods, are offered regularly for undergraduate and graduate students. The Computing and Systems group hosts a regular colloquium each semester for graduate students and faculty to meet and discuss cutting-edge research developments. We host research presentations given by our own faculty and students and visiting researchers. Our colloquium takes an informal format to provide a platform for discussion. We offer 3 graduate degrees. The first is the MCE, or Masters of Civil Engineering. This degree requires 30 credit hours of classes and can be completed in a 12-month period. This degree requires 6 courses in civil engineering, including at least 2 computing and systems core courses. 4 courses can be taken outside the department through, for example, the computer science, operations research, industrial engineering, mathematics, or statistics departments. We also offer a Master of Science degree, which requires 30 credit hours. 6 of the credit hours should be research credits to complete a thesis. The plan of study is developed with a thesis advisor to ensure that the student receives the research training through courses to complete a thesis. The PhD degree requires a total of 54 credit hours. Typically, 18 to 24 of these credit hours are fulfilled through courses, and the bulk of the credit hours are fulfilled through research. We offer a number of core graduate courses that are expected to meet the needs of graduate students in our group. These courses cover numerical methods, computer methods, modeling of civil engineering systems, computer-aided engineering systems, and advanced topics, such as high-performance computer modeling and evolutionary computation. This slide also indicates the semester, fall or spring, when each course is offered. Several civil engineering graduate courses are offered within more traditional domains, but overlap in interests and material with computing and system topics. These classes are listed here. There are a number of classes offered in other departments that our students have taken to benefit their degree and their research. As mentioned before, students can tailor their plan of work to meet their interests and research requirements. Graduates of our program find jobs at traditional civil engineering firms, government agencies, national labs, and universities. Because students are trained with skills in computing and systems analysis, many find interesting work at additional jobs that are not traditionally focused on civil engineering. One of our graduates, Sarat Sripathi, is a computer scientist at Oak Ridge National Laboratory. Sujay Kumar is another graduate of our program. He's currently a research scientist at NASA. These graduates have found value in the Computing and Systems program in preparing them for a career in computer analysis. Here are a few examples of the research projects that are ongoing in the Computing and Systems group. Dr. Joe DeCarolis has developed energy system models to address energy policy questions, such as how might the current 23% share of coal in the U.S. energy system change under future climate or energy policies. A team of researchers from the Computing and Systems group has collaborated to examine changes in water use from 1985 to 2010 across the U.S. This research identifies important trends in water use and how population change, water efficiency, and outdoor water use influence these trends. Dr. Murthy Gudati developed a non-destructive testing method to estimate the depth of pilings that support bridges. This method has been deployed to test bridges across the state of North Carolina. Another project was funded to develop a simulation optimization framework to identify the location of leaks in a water distribution system. The framework is enabled using high-performance computing and is being applied to help manage a water system for a city in North Carolina. A few examples of recent theses and dissertation titles is shown here. For example, an iterative simulation and mathematical programming optimization approach to leak detection in water distribution systems. Our graduate students have been successful at winning national awards. Elizabeth Ramsey is a master's student who won both a National Science Foundation and Fulbright Award to develop models of water supply and water use behaviors for a city in India. Sarat Sripathi won a paper award at the Supercomputing Conference for his work in creating a parallel optimization method for particle swarm optimization. We are always looking for motivated and creative students to join our program. Please apply online to graduate school for a master's or PhD in civil engineering with computing and systems as your concentration. Thank you.